Equivalent ratios can be found by multiplying or dividing both terms of a ratio by the same number. These equivalent ratios can be represented using a ratio table. We're going to look at this first example that says the ratio of boys to girls in a class is 3 to 5. Make an equivalent ratio table to show this relationship. Well, when I know that the relationship is 3 to 5, that means that for every 3 boys in the class, there are 5 girls. So I'm going to make a table that shows boys and girls, and I'm going to show that 3 boys in a class is related to 5 girls in the class. Now to fill out the rest of my table, I'm going to multiply these numbers. So the first thing I'm going to do is multiply by 2. And when I multiply by 2, I'm multiplying both terms. So I'm going to multiply my 3 by 2, which would give me 6. And I'm also going to multiply my 5 by 2, which would give me 10. That means that for every 6 boys in the class, there would be 10 girls in the class. Next, I'm going to multiply by 3. So again, I take my 3 boys, and this time I'm multiplying by 3, which would give me 9. And I take my 5 girls, and this time I'm multiplying by 3, which would give me 15. This means that for every 9 boys in the class, there are 15 girls in the class. Next, I would multiply by 4. So I would take my 3 boys and multiply by 4, which would give me 12. And I would take my 5 girls and multiply by 4, which would give me 20. This means that for every 12 boys in the class, there are 20 girls. And finally, I would multiply by 5. So I would take my 3 boys and multiply by 5, which would give me 15. And I would take my 5 girls and multiply by 5, which would give me 25. This means that for every 15 boys in the class, there are 25 girls. Julia's juice bar sells a juice that contains 5 parts apple juice for every 2 parts cranberry juice. Create an equivalent ratio table to show this relationship. So I'm going to create a table that shows apple juice and orange juice, and I'm going to show 5 parts of apple juice for every 2 parts of cranberry juice. To fill out the rest of my ratio table, I'm going to make sure that I multiply both of these terms by the same number. So again, I'll start out by multiplying by 2. So I'm going to take my apple juice, which is 5, and multiply by 2, which would give me 10. So that would be 10 parts of apple juice. And then I'm going to take my cranberry juice, which is 2, and also multiply by 2, which would give me 4. So that means that if Julia puts 10 parts apple juice, she would need to put 4 parts cranberry juice. Next, I'm going to multiply by 3. So I'm going to take my 5 parts of apple juice and multiply by 3, which would give me 15. And I'm going to take my 2 parts of cranberry juice and multiply by 3, which would give me 6. So for every 15 parts of apple juice, I would have to have 6 parts of cranberry juice. Next, I would multiply by 4. So I would take my 5 parts of apple juice and multiply by 4, which would give me 20. Then I would take my 2 parts of cranberry juice and multiply by 4, which would give me 8. Finally, I'm going to multiply by 5. So I'm going to take my 5 parts of apple juice and multiply by 5, which would give me 25. And I'm going to take my 2 parts of cranberry juice and multiply by 5, which would give me 10. Now, sometimes you have a ratio table that's partially filled out, and you need to find the missing values in the table. In order to do this, you need to actually look for parts of the table that are complete. And that means for this problem, I would need to look at a value where I know both the cups of flour and the cups of water. So when I look here, I see that I have 2 cups of flour, but I don't know how many cups of water. But when I look here, I know that for every 4 cups of flour, I have 6 cups of water. So I can make a ratio to show that for 4 cups of flour, I have 6 cups of water. And what I'm going to do is simplify this ratio? I can simplify this ratio, and I know that this is written as a fraction, so I can take 4 and 6, and they're both divisible by 2. So I can divide both of these by 2, and 4 divided by 2 would give me 2 cups of flour, and 6 divided by 2 would give me 3 cups of water. So that means that for every 2 cups of flour, there are 3 cups of water. Well, when I look in my table, I see that I have 2 cups of flour, so I know that 2 cups of flour has 3 cups of water. Now I can take this and I can fill out the rest of this. So, since I know that the rate that I'm using is 2 cups of flour for every 3 cups of water, I'm going to look at the next value in my table. The next value is 6, and for that there are 6 cups of flour. Well, I'm going to set this equal to 6 cups of flour. And I put this in my numerator because I have flour in my numerator here. So what I need to know is how many cups of water would this be? Well, I need to look at how would I get from 2 to 6. Well, to get from 2 to 6, I would multiply by 3 because 2 times 3 gives me 6. That means to get from 3 to x, I would also multiply by 3. And 3 times 3 gives me 9, which means that for 6 cups of flour, I have 9 cups of water. Now I can do the same thing, and now I can look at 12 cups of water. So I'm still using my same rate, which is that for 2 cups of flour, I always use 3 cups of water. But this time, I know that I have 12 cups of water. So for this one, I don't know how much flour I have, so I'm going to use x in my numerator to represent the number of cups of flour, but I know that I have 12 cups of water. Now, to get from 3 to 12, I would multiply by 4 because 3 times 4 gives me 12. So to get from 2 to x, I would also multiply by 4. And 2 times 4 gives me 8, so that means that there are 8 cups of flour when I have 12 cups of water. Now I'm going to look at 10 cups of flour. So again, I use my rate of 2 cups of flour for every 3 cups of water. And in this case, I have 10 cups of flour, so that's going to go in my numerator. And what I don't know is how many cups of water I would need. Well, I know that to get from 2 to 10, I would multiply by 5 because 2 times 5 gives me 10. So to get from 3 to x, I would also need to multiply by 5. And 3 times 5 gives me 15, which means that for 10 cups of flour, I would need 15 cups of water. This table shows the relationship between the number of donuts you buy and the cost in dollars. So we're going to find the missing values in this table. Again, the best way to do this is to look at the values that I know. So I know that 12 donuts cost $3, and I see that in this very first row. So I'm going to simplify this, and if I look at both 12 and 3, I know that both of these can be divided by 3. So 12 divided by 3 would be 4, so that's 4 donuts, and 3 divided by 3 would be 1, so that's $1. That means that the cost of 4 donuts is $1. So I'm going to use this rate to fill out the rest of my table. I notice that my second row is already complete, so I can skip to my third row. In this row, I don't know how many donuts I have, but I know that the cost is $9. So I'm going to use my rate, which is 4 donuts cost $1. And for this, I know that the cost is $9. So I'm going to put $9 in the denominator because I had dollars in the denominator here. What I need to find is how many donuts this would give me. Well, I know that to get from 1 to 9, I would multiply by 9 because 1 times 9 gives me 9. So to get from 4 to x, I would also multiply by 9. And when I do 4 times 9, I get x equals 36. So that means that 36 donuts would cost $9. Now we're going to do the same thing, but this time we know that we have 48 donuts, so we need to know the cost. Again, I'm using the rate of 4 donuts cost $1. And this time, I need to know the cost. So this time, I don't know how much these donuts cost, but I do know that I'm going to purchase 48. Now, I'm going from 4 to 48. To get from 4 to 48, I would multiply by 12 because 4 times 12 gives me 48. So to get from 1 to x, I would also multiply by 12. And 1 times 12 gives me 12. So for this, I know that 48 donuts are going to cost $12.